Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor. In my today's lesson, I'll be discussing differential equations, and particularly I'll be looking at reducible to variable separable method. That is type 2 of variable separable. So in previous lectures, we did variable separable methods, and variable separable method is a kind of method that involves having a differential equation that you can separate the variables, like you have x and y in the differential equation. So if it is possible to send all of the x expressions on one side of the equation and all of the expressions with y on the other side of the equation, then it means that you can apply variable separable method by integrating both sides of the equation. But in some cases, it might be somehow challenging to separate the variables. So what you need to do is to look for some other expressions that could be substituted, especially expressions that are in two variables. Like you see in this problem, we have x plus 2y. So because you have these two terms, they are in two variables. If we substitute these two terms with a single variable, then we're going to have a differential equation that can easily be separated in terms of the variables. So we will say let u equals x plus 2y. Differentiate u with respect to x. We have the derivative of u divided by the derivative of x is equals to 1 plus 2 dy by dx. So what do we do next? We solve for dy by dx. So du over dx minus 1 is equals to 2 dy by dx. So we can divide both sides by, we can multiply all sides by 1 over 2. So we're going to have du over 2 dx minus 1 over 2 equals to dy by dx. Now we do the substitution in the problem. We have this now to just be du over 2 dx minus 1 over 2 equals to 2 all over. Now this the first two terms here is just u minus 3. So we have a differential equation now that we can easily separate the variables. So let's simplify. We find the LCD for all of these terms. So it's like saying 2 u minus 3 dx. So each of these denominators can go into this. 2 dx goes here. 2 and dx cancel. You'll be left with u minus 3. So it's u minus 3 times u minus. So 2 goes into this. 2 and 2 cancel. You just left with u minus 3 dx equals. So u minus 3 goes into this. U minus 3 cancel. You'll be left with 2 times 2 is 4 dx. So all of the terms with du must be on one side of the equation, and all of the terms with the x must be on the other side of the equation. So we have 4 dx plus, this goes across, u minus 3 dx. So u minus 3 dx equals, now we can factor out dx. So when the x is factored out, you have the x like this. Then what is left here is just 4 plus u minus 3. So we're going to have u minus 3 dx. Is it okay? This is du. Du now is equal to, now u 4 minus 3 is 1, so it's positive 1 times dx. So there's the x, so we need this entire expression to be in x. So since this is u, we must get rid of it. So this cancels this one. We now have u minus 3 all over u plus 1 du equals to dx. So we can integrate both sides to find our general solution. So for this side, we have the integral of u all over u plus 1, right? And then minus, so there's the u, minus 3, the integral of 1 all over u plus 1 du equals, the integral of the x is just x. So we separated this, so we took u all over u plus 1, and then that's how we separated it. So what do we do? Right here, we can either apply long division, we divide this by this expression, or we bring in some trick, thereby saying u plus 1 minus 1. So this is same as saying u. So we can divide this by u plus 1, and we divide this by u plus 1. Du minus, so it is 3 the ln of u plus 1, or equals to x. So this is just, right here is just 1. So it's the integral of 1 du minus the integral of the u over u plus 1 minus 3 the ln of u plus 1 equals to x. So we can now integrate. This is just u minus the ln of u plus 1 minus 3 the ln of u plus 1 equals to c, x plus some constant c. But these two are like terms, so we can add the coefficients since they are like terms. So it would just be, now u is x plus 2y minus the ln of, so this and this, we add a coefficient, the coefficient is 1, so it's minus 1, minus 3 is minus 4. Let me put it, it's minus 4. The ln of x plus 1. So x is, let's say u plus 1, and u is x plus 2y, and then plus 1 equals to x plus c. So what happens? This x can cancel this other x across. So we just left with 2y minus, so we can divide all side by 2. We can divide all side by 2. So we have y to be equals, we can send this term across. So it becomes positive ln of x plus 2y plus 1. Then we have plus, now this c over 2 is still a constant, so we can just replace it with a. Now we want to rewrite, you can leave it here, or you can just rewrite it as the ln of x plus 2y plus 1 raised to the power of 2, because arrow the ln of a is equals to the ln of a raised to the power arrow. So we can just take this 2 and put it to the power of this expression. Then we say plus a. But this a, we could rewrite this a as ln of a so that it reduces the problem. So ln of a, and ln of a plus ln of this expression, it becomes ln of a times x plus 2y plus 1 raised to the second power. Because we know that the ln of a plus the ln of b is equal to the ln of ab. So this a and this is b, so ln of a plus the ln of b is equal to the ln of ab. And ab is the same as b is, so it doesn't matter. Now this is our general solution of the differential equation. So even if you stop here, it's okay. You want to stop here, it's okay. Whatever way you want to do it, as per what is required from your instructor. So thank you very much. See you in our next lecture. Please don't forget to subscribe. Thank you.